All right, so yesterday for your homework, which everyone did, here's what we had. So we had a couple of things that we needed to check to see if it was enough to prove triangles were congruent. We already did this yesterday. We checked side, 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 and it turns out that does work. So when we have two triangles where they have a pair of matching sides, a pair of matching sides, and a pair of other matching sides, it turns out that's enough to prove the triangles are congruent. And at first we're going to be like, well, duh. If everything's the same, then of course they're congruent. But here's the deal, moron. Okay? Not everything is congruent. What about the angles? We don't know that for sure. Hello.
When does this do?
As soon as possible. Fine.
Okay.
Yes.
Can I get a cup?
Yes.
Yeah.
Yes. Get us all a drink. So,
I can just
all the sides are the same, which turns out locks in our angles, which makes them all the same as well. So if all the sides and all the angles are the same, the triangles are congruent. So all we need to know is that all the sides are the same, and we get all the angles for free. Yeah. Yes. Can I take this at any other time? Literally any other time. Yes. You're asking if you can turn that in, right? Yes. Any other time would be great. Literally any other time. All right. However, knowing all three angles, so if we have two triangles, and we know that they have matching angles, this will not be enough to prove they're congruent. It doesn't prove they're not congruent, because they could be, but it's not enough to prove they're congruent, because imagine we have two equilateral triangles, right? Equilateral triangles have equal angles and equal sides. So imagine an equilateral triangle. If all the angles are equal in an equilateral triangle, what's going to be the measure of each angle?
The same thing.
The same thing, which will be what? We can actually figure it out. So now we're coming back from Sachs Club. Let's go. If I have an equilateral triangle, that means the angles and the sides are equal, right?
Yeah.
So if all the angles in an equilateral triangle are equal, what will all the angles measure? Mark. 60, because the internal angles of the triangle always add up to 180. So if all three angles are equal, they're all going to be 60. 60, 60, 60 makes 180. So if I have two triangles that are equilateral, 60, 60, 60, it looks like they could be congruent, but they actually won't necessarily. So imagine an equilateral triangle. Now imagine a bigger one, right? They're not going to be congruent. They're going to have the same angles, but they're not going to be congruent. One's going to be bigger than the other. So just having angles all the same is not enough to prove that the triangles are the same. They could be, right? They could be, but we don't know for sure. So it's not enough. We need some more information. Yesterday we did this one in class as well, angle, side, angle. That's when we have two triangles where they share an angle, a side, and an angle, in that order. Notice that the side is in between the two angles, and it is as well on the triangle. That is key. So if you haven't been paying attention, notice that the angle on each side of the side is the same on the triangle. So we have angle, side, angle in that order with a side in between. Okay? That is different than another one we're going to look at. So when we have an angle, a side, and an angle like that, it turns out it does make the triangles congruent. It always will. That's all the information you need. And the reason for that is when you draw a triangle with two angles and a side matching, like this. That looks to be 5, that looks to be 5 as well. And I set two angles like this. As long as I make sure those angles are the same, which, I sketched it so they're not perfect, it'll end up making the same triangle. See how they automatically intersect? So it'll end up making the same triangle just after making these the same. So angle, side, angle is enough to prove that the triangles are congruent. The ones I wanted you guys to check for homework were angle, angle, side. Everybody's favorite. Angle, side, side. And one more. Does anybody remember?
Side, angle, side.
Very good. Side, angle, side. Those are the ones I wanted you to check. So since everybody did this, I'm going to run through this really quickly and you'll just watch, right? Good. So let's try side, angle, side first. So we have two sides the same with an angle in the middle. So, here I go. I will myself a side. Let's use a thicker color. Okay, here we go. So we're going to test side, angle, side. So that means we're going to have two sides and one angle in between them. I'm going to start with the side. Let's make it 5 and make it 5 over here. So again, as long as they're congruent, doesn't matter. I'm drawing it to scale so we can show that it works. So both are 5. Now we need an angle measure. So somebody give me an angle that is acute and a multiple of 10. 90. Can we do not 90? 90 isn't acute. No.
70.
Say again.
70.
70. 70.
Yeah.
Got it.
0.
So going this way, that's 70 degrees. Everybody see that? From here to here is 70. The other way would be 110. That's why there's a 110 there. Right? If we went from here to here, that's 110. So I'm going to draw 70. It doesn't matter how long this is. Remember, we only have one side that's locked in that has to be this long. Can't go any further. So 70, right? Keep going further. Here's 70 over here. So those angles are congruent. So far we have side, angle. Now we need another side length. So we're going to determine a side length for both of these. That's going to match. Now you'll notice that I can't just count boxes because it's going off at an angle. So I'm going to use this. So give me a number between 1 and 3 for inches. Give me a number. 2. All right. So we're going to measure up 2 inches and then we're going to cut it off there. Oh wow, amazing. 2 inches exactly. That's pretty rad. Wow. Wow, that's amazing. So our triangle's going to get cut off there. So now, in order to form the triangle, there's only one thing I can do, right? Connect it like this. And it ends up making the same triangle. So it turns out having a side, an angle, and a side that match is enough to prove the triangle's congruent. So side, angle, side does work. Remember, side, angle, side is when you have two triangles that have a side that matches and a side that matches, and another side that matches, with an angle in between that matches. That is enough to prove that they're congruent. All right, let's try ASS. We're praying that this one works, right? That way you can write this down on a test and I won't write it wrong. Yes. All right, so we're gonna try angle, side, side. Here we go. So I'm gonna read this backwards and do side, side, angle, because drawing an angle without drawing sides is kind of weird. So I'm going to start out with some sides, right? It's the same forward and backwards, right? Ass versus ass backwards, same thing. So let's draw a side. Carver, give me a number between 1 and 10.
7.
7, all right. So I'm going to make the side length 7. Let's use brown. Here's 1, 2, 3, 4, 5, 6, 7. And here's 7. 1, 2, 3, 4, 5, 6, 7. All right, so we have matching sides. Cool? So now I'm going to do another side, consecutive sides, right? Sides right next to each other. So I'm going to draw another side. Because I have to draw it at a non-specific angle, right? Because we don't know about the angle between those sides. I'm going to have to draw it at some weird, trajectory. So I'm going to use this to measure it out instead of counting squares. Can somebody give me a number 1 through 4?
3.
3, awesome. So 3 inches at a random angle. And I think you're going to be able to tell very quickly that this one doesn't work. So 3 inches at a random angle. Also 3 inches at a random angle. Because again, the angle doesn't necessarily have to be congruent for us to say they're the same. So I think right away you can tell these aren't going to end up being the same triangle. And I've only done the 2 sides. The last angle is going to be whatever angle this is. And it turns out this angle has to be a specific thing. It has to be whatever angle connects these guys and these guys, right? So already I can tell the triangles won't be the same, right? So it turns out ass does not work, which is a shame, right? Yes. So neither ass nor ass backwards works, which makes sense because when you say something is ass backwards, it usually means it doesn't work, right? Back asswards, something like that. Anyway, so those don't work, except in one case actually. And we don't call it ass because, not because teachers are afraid to say it, which is probably also a reason, but because this only works in one specific case, and it only works when you have 90-degree triangles. So if the angle you're talking about in an ASS is 90 degrees, it does work. So here's a length of 4, and here's a length of 4. And we're going to say this has to be 90 degrees. So I'm going to draw a 90-degree angle. That's really easy to do with graph paper. It's some line going off at a 90 degree. So we have our A, S, and then we need to make our other S. So give me a number on here, 1 through 4, for my hypotenuse. 2, okay. So in order to do 2 and make it a triangle, I have to make it a certain angle. So there's 2 in length. And here's 2 in length. In order for it to connect with the side, it has to go at a certain angle, which ends up making the same triangle. So it turns out ASS does work as long as that angle is 90. So we have a different name for this, right? Because AS only works in one case. It's when we have a right triangle. So when we're talking about these sides, we have different names for them. That's a leg, and that's the hypotenuse. Only right triangles have a hypotenuse, and the hypotenuse is always the biggest side, and it's always across from the 90-degree angle. So we call this theorem HL, hypotenuse leg. Hypotenuse implies 90 degrees because it's only right triangles have hypotenuse, right? So we call it HL.
Wait, what do you mean like by how? What do you mean like by bigger side?
So see these 3 sides?
Yes.
The hypotenuse will always be the biggest side, and it's always across from the 90
okay.
degree. Does anybody know why the hypotenuse will always be the biggest side in a 90-degree triangle? Yeah.
Because it's diagonal.
It's diagonal, so diagonals are going to be longer, right? That's true. Anybody have another way of describing it? You're right, Katie. Anybody have another? There's 3 ways we talked about in our previous classes. That was one of them. Anybody else know why the hypotenuse is the longest? The reason I don't like Katie's a lot is because technically that's a right triangle and that's not a diagonal, right? And that is the hypotenuse. So it's not always diagonal. So imagine this is an angle, part of a triangle. Can you already tell what I need to do to complete it to make a triangle? What would I need to do to complete this? Yeah, to make a triangle, I'd have to put a line from here to here, right? Now what if I increase that angle? What happens to that side? That blank side that I'm missing gets bigger, right? So it turns out the bigger the angle, the bigger the opposite side. In a 90-degree triangle, the biggest angle will always be the hypotenuse. How do I know that'll always be the biggest? Well, because the internal angles always add up to 180. So whatever's left over has to be split between them and 90. So at most, this could be like an 89.99999999999 angle, because I have to have a little bit left over for this guy, right? Otherwise, it's not a triangle. I only have 2 angles. Right? Can't be 0. So that will always be the biggest angle, which means this will always be the biggest side, because it opens up the most. Yeah.
Is it possible to have the H thing when there's like 2 of them are equal, like the lines?
Yes. So if we were to do a right triangle like this, where it's 1, 2, 3, 4, 1, 2, 3, 4, these are both equal. Here's our right triangle, right? And so we can either say side, angle, side, if we have 2 triangles that are matched up in that way, right? To say they're congruent. Or we could say HL says they're congruent, because it is a right angle. So AS does not work. If you want to write AS on your paper, or SSA, AS backwards, probably what you want to do is actually write HL. So HL does work. That's when we have 2 right triangles, where we have a hypotenuse and a leg matching. That does work. AS does not. Now, sometimes you'll want to write AS on your paper, and it won't be a right triangle, which means you can't use it at all, right? But HL does work if it's a right triangle. So if you want to write AS and it's a right triangle, really what you want to write is HL. Okay? There's a joke to be made there. All right. Double AS. AAS. First off, I guess we can fill out this little chart. We have an angle and 2 sides. Shared angle, side, and another side. side doesn't work. Let's do AAS. This one's kind of hard because it has two angles and only one given side. So I'm going to start out with the side. Make things easier. I'm going to read it backwards just for demonstration. But they're the same thing. So here's a length of 5. Here's a length of 5. They are congruent. So there's our congruent side. Now we need two consecutive angles. So Katie, give me an angle.
You want it to be
Acute and a multiple of 10.
40.
We'll go with 40. That's a multiple of 10.
2.
Yeah, it doesn't matter how long it is. It's just that that angle is 40. Because it's a multiple of 10. There's 40. I told you first hour is similar, or fourth hour is similar to first hour. It's different, but it's similar. All right, 40. So they're both 40. Now I need another angle. Now you'll notice that when I do this angle, in order to make it a triangle, I have to kind of slide how long this segment is, right? To make sure it actually does intersect. So give me an angle that is acute and a multiple of 10, Katie.
20.
20, there you go. All right, so in order to do a 20-degree angle here, there's 20. I want to make sure it actually does intersect. So it looks like there. So there it is. That will be 20 degrees. And notice it kind of forces me to make a specific triangle. The same thing here if I go 20. I try to line it up where that's going to make a 20-degree angle. Looks like there. And those triangles will end up being congruent. So AAS does work. Are you guys feeling better about this today? I know yesterday was very confusing. Do we feel better now? Okay, you might not feel amazing. You should feel at least better. So it turns out, if you know two angles and then a side are congruent, so two consecutive angles, angle there, angle there, angle there, angle there, and then one side are congruent, that is enough to say the triangles themselves are congruent. Okay? Same thing backwards, SAA also works, right? Side angle, angle. The only ones that don't work are ASS and AAA. So to remember that AAA doesn't work, I think of two equilateral triangles. I'll draw them out, just in case you didn't get the analogy before. Equilateral triangles have all equal angles and all equal sides, which means an equilateral triangle always has 60, 60, 60, right? So here's a 60-degree angle between here and here. And here's a 60-degree angle here. So that's 60, that's 60, that's 60. So all three angles are the same. But I could also draw another triangle that has 60, 60, 60 that is not congruent. I can do it very easily, just like this. I have two triangles here, a bigger one and a smaller one that have all the same angles, right? 60, 60, 60. Are you with me? All the angles match for these two triangles, right? But they aren't congruent. So AAA is not enough to prove, right? And then I know that AS doesn't work because AS backwards, right? Means it doesn't. HL is the one you really want. All the others work. So I don't memorize all these, ASA, AAS, all that. I just think which ones don't work. AAA and AS. Okay? Here's your homework. We're going to do a couple together. Get a feel for it. Your quiz this week is going to be one of the easier quizzes of the semester, which means I hope you knock it out of the park. It's going to be very similar to this worksheet. We're not going to be proving any of these theorems like SSS or SAS. We're going to be doing that next week. Right now, we're just going to practice using them. Not all of these triangles on here are congruent. Or at least, I'm not guaranteeing they are. It's your job to see if we can prove them congruent. All right, class, true or false?
True.
True or false? If I can't prove something congruent, it means it's not congruent.
Yes. True. Wait.
You say true. Why do you say false, Quinn?
Because someone else can prove it.
Just because we can't prove it congruent doesn't mean they are. For instance, or they aren't. Pretend I measure these out perfectly, so I know they're congruent. But do you know enough information to prove that they are? No, right? They might not be. They could be slightly off, right? For all you know. So just because there isn't enough information to prove it is congruent, doesn't mean that they aren't. We don't know. They could be congruent. There's not enough information to tell one way or the other. Same thing with some of the triangles on here, potentially. So just because they're on there doesn't mean there's a way to prove it. Doesn't mean they're not congruent, but it means there might not be enough information. So looking at number 1, here's what they gave us. They gave us that we have 2 pairs of matching sides, and we have 2 pairs of matching angles. Let me use a different color than that. Let's use blue. So we have 2 pairs of matching sides and 2 pairs of matching angles. That is not enough to get it done. So far we just have SA, right? Is there more information that we can get from this to make something work, or is that just there's not enough info? I'm going to tell you that there is more information here that we can get. Seeing it is half the battle, so we're going to spend a lot of time today just looking at this. Does anybody see anything more on this one right here, number 1?
You do the side like this way?
GI.
Yeah.
So notice that they both share GI. This triangle shares it with this triangle, which means it's going to be congruent for both, right? This is a shared side. This is a super common thing. So everybody that's not paying attention, including Abe, a shared side between 2 triangles is a really common thing for somebody not to label that you need to find. It's shared between the left side and the right side, so it's going to be the same for both. So we have side, angle, side, which is enough information to prove the triangle's congruent. So by side, angle, side, we know triangle FIG and HIG are the same. They're congruent. Again, focus on one triangle at a time. Side, angle, side is what we're doing here, right? Side, angle, side matches up here. Side, angle, side matches up there. So by side, angle, side, they're congruent. Macy, you with me? Not at all? Okay. Let's look at number 2. So Macy, they've given us that this side is congruent to this side, right? Those are the same length. They've also given us that this side is congruent to this side, so those are the same length. Right now that's not enough information. All we have is side, side. That's not one of our theorems that proves they're congruent, right? We need at least 3 things, unless we're talking about a right triangle, okay? So there must be missing information in this problem that we're not getting, or it's impossible and we can't tell. Does anybody see the missing information? Quinn sees it. Katie.
Shared side.
They have a shared side. See how the bottom triangle and the top triangle, we didn't say series, we said shared side. So, they share the side. See how the triangle in the bottom shares this side with the triangle on the top? So that means it's congruent for both, right? And so now we have side, 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 which is enough information to prove the triangle's congruent. Turns out if all the sides are the same, all the angles will also be the same. Jenna, how you feeling?
Good.
I figured you would. So same thing for the first one, Macy. That shared side right there we got for free. So we have side, angle, side, which is enough to prove them congruent. Feel a little bit better? Okay. Look at number 3. Here's what they've given us. We have an angle here and an angle there that are congruent. And we have a side that's congruent to another side. So far we have an angle and a side. That's not enough to prove it. So we must have other information or the problem is impossible. Or at least we can't tell, which is separate sides, right? It's not as easy as the other two. They don't share a side. Think back to first semester. You can do it. Katie.
They share an angle.
Kind of. They don't share it because they're not overlapping, but there's something else. Vertical angles, very good. So check out angle here and angle here, right? These two angles are the same by vertical angle theorem, scissor theorem, right? Your words, not mine. So now, how do we know the triangles are congruent? By angle with a side in between and an angle. So again, if I just look at the left triangle, angle, side, angle is what they have in common. Cool? In that order. It's not angle, angle, side. It's an angle, a side, and an angle. Some of you might say, wait a minute, but if I go around the triangle this direction, I get angle, angle, side. But you'd be skipping over an angle, wouldn't you? Right? So angle, side, angle, not angle, angle, side, right? You have to skip an angle there. That's not okay. Angle, side, angle. What do you notice about 4, 5, and 6? Right off the bat? They all share a side. Well done. So those are all going to be given to us for free. Let's color code these. We have two angles at the top that are the same, and two angles that are the bottom that are the same. So focus on one triangle at a time so you don't get goofed. Look at this bottom triangle. Is that enough to prove the triangles are congruent? Yes, we have angle, then a side, then an angle. Some of you guys might have got confused and said angle side, maybe angle, angle, side, right? But again, we focus on one triangle at a time. Angle, side, angle is what we have here. You smell what I'm stepping in? Okay. Very common mistake is to say the wrong theorem because you're going too fast. Don't let that happen to you. Angle, side, angle. Number 5, this top right corner and this bottom left corner are going to be congruent. And then top left and bottom right. Focus on one triangle at a time. Is that enough information to prove them congruent? And if so, what theorem? Focus on one triangle at a time. Angle, angle, side, right? In that order. Angle, angle, side. You could have also, Macy, said it backwards. Side, angle, angle. Right? Same thing. Angle, angle, side is the same thing as side, angle, angle. I like writing angle, angle, side. I don't know. It just sounds better to me. Alphabetical order, maybe. Either are valid. What would not work is angle, side, angle. You don't know that yet. Right? We don't have angle, side, angle here because that's an angle from another triangle. Focus on one triangle at a time. Angle, angle, side. Okay. Common mistake is to jump triangles. Don't do that. Number 6, we have matching sides, and we have a set of matching angles. I hate when the angles are next to each other that match. It's annoying. Is that enough information? And if true, if it is, then what's the theorem? Marissa, what's the theorem that makes those two triangles congruent? Number 6.
I don't know. Wait, I don't know any of the theorems. So, like the A thing?
Yeah.
Angle, side.
Angle, side is ass, and that doesn't work.
Wait, angle.
And it's not angle, side because it would be angle, side if it was ass, right?
Side, angle.
Side, angle, side. Very good in that order. The angle's in between the two sides. So side, angle, side. Again, if you want to say ass, either you really meant this, or you meant HL, or it just doesn't work, right? So don't write ASS. That is not one of them. Or SSA. It's a very common thing to see. Most people are good enough where they see ass and they go, oh, don't write that. But SSA, a lot of people don't think about. Look at number 11. Self-development point on the line. I'm going to tell you right now that they are congruent. How do you prove it? Yeah.
It's like J and L are right angles.
Nope, we don't know that for sure. Nope. Couldn't I imagine I could move it, right? It's flexible. It's not labeled in. And those angles would still be the same. no. It's my wallet. Notice it has no cash. Got $8 until Friday. $8 until Friday. And then I'll have a paycheck again. $8 is the most I've had in savings in forever, guys. This is a sign of the time. Okay. You know how many Jack's pizzas I can buy with $8? 3.5, baby. What?
See, Gisopoulos was a bartender on top of being a math teacher.
Rad.
That's how we had extra money, I guess.
I'm doing that in class actually today for algebra. I look in the back. Tending bar.
The geometry teacher was just a bartender too. I have to the bar.
I saw that today and I started laughing.
All right, number 11. Let's see what we do have. Well, first of all, what do you notice? Macy, what do you notice about this one? Shared side. She's on fire. So they have shared side, and they have two sides here that match up, and two angles here that match up. This is where colors really gets, helpful, guys. Right? So you probably want to say ASS, but it doesn't work. Or maybe you want to say side, angle, side. But here's the problem, right? We don't have a side, angle, and a side, right? We have a side, an angle, and a gap, right? So we have SSA or ASS, and they're not right triangles. If they were, it would work, right? There's another way to actually make this work. And it's tough. I'm offering self-development for it. 1 point. We had one person solve it in the third hour. Actually, we had two people solve it in the third hour. In fact, a former fourth hour alumni, Ellie, solved it in third hour. I am immensely proud of Ellie. First of all, she had amazing hair yesterday. Second of all, she killed it today in math class. Speaking of amazing hair, I like your hair. I always like your hair, Marissa.
Oh, thank you.
I already complimented your hair. I say stuff about your hair every day, Diana, in my head at least, okay? But I don't say it out loud. Katie's is a work in progress.
Yeah, I know. I woke up at 7:30 this morning.
It actually looks fine.
I woke up 2 hours.
My hair's a
Why
frizzy
do you
mess.
get
I've been
so
brushed out. I got in the shower. I was on the bed.
What is the
got
point of
curly.
getting up?
But instead of commenting on everyone's hair, I will just say this. Mark's hair is the best and always has been. Facts. Huh? Jesus on this earth.
And then the side
No.
Side side angle, that'd be ass backwards. That doesn't count. Can't do ass backwards.
You know what?
I know, right? We'll come back to number 11. Look at number 13 and 14.
It reads out to me.
It does, but that doesn't mean it works. Turns out ass doesn't prove it. Right, we prayed earlier that it would, but it turns out just knowing that information doesn't work.
Side angle.
Side angle and ass doesn't work. Either forward or backwards, ass does not work. Here's the reasoning, guys. Check out ass. Guys, check out this ass. All right. Check out ass or sasa. Okay? Either way, ass or ass backwards is wrong. Okay? So look, I have two triangles that share a side, and they share another side. So there's my two sides. And then the angle that they share is the angle I would make here. But I can't even do that, can I? Right? So just because the sides are the same, and then we have one angle that's the same, is not enough to prove the triangles are the same. Only if it's 90. Right? If it was 90, it would work. But those aren't 90 on number 11. We don't know that they
They
are.
can be like a leaning 90.
Yeah, but they're not. Okay? So if they were 90, it would work. Turns out they don't have to be, and we can still prove that true, but it's not going to be using ASS. You have to get more clever. This is a tough one. Okay? It harkens back to last semester, and a lot of you guys have forgotten about that. And it's tough either way. Great job to Ellie. All right. What do you notice about 13 right away? Macy. Yep. So by side, 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 they're going to be the same, right?
Yes.
What about 14? Aiden, what do you notice about 14 right away? Again, noticing stuff is probably more important than even the theorems. Right? That's going to be the key that's going to get you the answer. So what do you see about 14? There's some information that helps us solve it that isn't given to us.
It's going to be S, D,
Where do you see that angle? Because I've got sides. Where's the angle?
Angle's gonna be in between them.
Exactly. This angle right here by vertical, right? So we have SAS. Good. Look at number 1 down below. It says FIG. Triangle FIG is congruent to another triangle. This is kind of weird.
Wait, yeah, where's that come from?
All right, so this is kind of weird. I did not make this worksheet. Spoilers. I didn't want to make all these diagrams by hand. It was a pain.
Yeah, can we cross it out?
Right? No. Here's the point of the bottom, at least the way I'm going to do it, okay? When you write two triangles are congruent, you can't just write it however you want. So for instance, look at 13. We know that FIG, the left triangle, is congruent to the right triangle. But we're not going to write FIG is congruent to GIH. We're going to try and match up the letters as much as possible. FIG is congruent to HIG. So when I write this, I'm going to write FIG is congruent to HIG in that order. Notice how the G and the I match up. They're in the same spots. That helps you because it tells you that if these triangles are congruent, both angle G's will be congruent because they're in the same spot. Both angle I's will be congruent because they're in the same spot. And both F and H, because they're in the same spot, will be congruent. So writing it in the correct order is important. Turns out if you were to look at any of these triangles on this page where it says FIG, that they would match up with the same thing. So you can go back to number 1 like it wants you to, and look at FIG and say it's congruent to HIG, or you just cheat over here. Okay? But in general, go back to the number they say. So for number 1 they're asking about, that's number 1 on the first page. FIG is congruent to HIG. Okay? Order matters. Let me say it again. It'd be a really dumb way to get stuff wrong. Order matters. FIG goes with HIG. Match up the letters as much as possible, because the angles will match too. Yeah.
Are they all gonna be congruent then?
Yes. Every single triangle on here is congruent and provable. 11 is probably the toughest. That one we'll talk about tomorrow when WAC kids are gone and we have a shortened class period. Sorry, Jenna. Watch the video while you're in the bus.
Oh, yeah.
Yep.
I'll be like 10 minutes.
It'll be fine. You just watch the video while you're in your bus, right? Super cool. Super cool. And that's it. That's basically what your quiz is going to be. We're going to have a little bit on top of that. I'll talk about that tomorrow, and then especially on Thursday when we review. And then you're going to knock this quiz out of the park, right? This quiz is worth the same as any quiz that you take this semester. Okay? Which means it's going to be worth just as many points as the hardest quiz you take. So balance this out.
11.
Okay? Make sure you destroy this first quiz. 1 self-development point on the line for number 11 if you can prove it before tomorrow. And I don't care if you talk to Ellie about it. Or Zayden. In fact, I would encourage you to. Because then in order to come in here and tell me it, you would have to learn it. Which I think is worth it. That's the whole point. So I don't care if you were cheating to get that answer.
It's the second time 420's been a safe now.
My algebra class today has a question with 420 in
I
it.
wish I was.
I make my own worksheet.
So is this homework?
Yep. That's it. First week's not too bad. Next week we'll be proving these theorems. Not just giving examples like I've been doing with my drawings. Like that's not a proof. Like that is not a proof.
I can't do 11. My God.
Huh?
11 is a
Yes. Yes, I can. Are we talking about down here? Shared side, yeah. So we have angle side, that's AAS, right? And then this one is going to be angle side angle. Again, make sure you're looking at one triangle at a time. So you know, even angle side and an angle. Yeah. Yeah, if you look at both triangles, sometimes that can happen. It's super common. Make sure you look at one at a time. Very heavy. Very.
Really, Marissa?
I heard you guys have a Spanish quiz today.
We do? We didn't.
I heard you do. Michaela said you did.